All right, so picking back up. So we were doing this problem. We had this box. We're optimizing the volume of the box, trying to figure out what the max volume is for the box. So I need to FOIL this. So if I do that, I'll have x times, let's see, what is this, 75 minus
10x minus 15x minus 2
plus
2x squared.
yeah. And then I can simplify that middle.
All that is multiplied by x.
Yeah. And then I can multiply the whole thing by x. So I'm actually going to flip it so that I have the terms in order. So 2x cubed minus 25x squared plus 75x is equal to volume. And then I'm trying to check something really quick. What's this, 5.4? Just want to make sure that I know how they want their answer written. All right, so we're going to take the derivative here now for part D, because it says to confirm your result from part C, which said to use a graphical method to find the max volume and the value of x that it gives. So let's just look at C really quick. So on your calculator, you're going to graph this function in y equals and you are going to have to change the window of your calculator to get it to fit. Still didn't do that enough. I'm kind of just playing with the window. I know your x value only needs to be like 0 to 5. I'm playing with the y value, trying to figure out what it needs to be. Y'all know how to change your window, right? Click window and change it. Still not enough.
I'm getting the 2 points right next to the axis, the y-axis.
Did you hit zoom standard or whatever?
I did.
Yeah, so it's going to look like that because of the way the graph is. The graph is really weird. Well, I mean, it's not. I mean, it's weird, but it's not. You have to change your window, and as you change your window, it'll adjust it. Okay, well, I'm at the y being 0 to 60, and I'm still not quite there, so I'm going to change this like to be 30 to 70. See what happens. Oh, I finally got it. Changing my window, I did 0 to 5 on my x-axis, and then on the y-axis, and I did in increments of 1. Y, I did 30 to 70 increments of 1 is what ended up giving it to me. Basically, I know I want max volume, so I'm looking for the highest point on my graph, and so that is the highest point. So now, do y'all remember how to find a max?
I know how it works. I don't remember the buttons.
Okay, so second, and then the trace button, which is calc, and then you're gonna find maximum.
Oh, then you just hit the left bond.
Yep,
Or whatever it's called.
left bound, right bound.
Bound.
And then it'll want to guess.
Changed your window
I changed my window to 0 to 5 for the X, and then 30 to 70 for the Y. Huh? Basically, I just tell that something was off, and I kind of just made some assumptions about the window and what it needed to look like. In terms of, like, also knowing some stuff about the base of the box. I could have left it 0 to 10 on the X, but then the Y, I was trying to find the max value, so I was trying to go to the area, and then as I went, I could see that the X was going to be in a smaller region, so I just adjusted it, basically. So we have our max at X is equal to 1.96 and Y is equal to 66.02. So basically for this, the way they want you to write your answer is that the max volume is 66.02, and did it give us units? Inches squared, or inches cubed, I should say, when X is equal to 1.96. So basically, that just told us that that is, our max volume and where it occurs. To confirm the result, basically, we are just going to take the derivative of our volume function and set it equal to 0 to find this. So the derivative of that would be 6x squared minus 50x plus 75. And then if you set that equal to 0, I would want to know, is there any way that we can factor that? Or can it be factored? So any ideas what we should do instead?
Quadratic formula.
There's
Yeah.
I literally pulled that out of the back of my mind.
Literally out of the back of your mind. All right, so negative b, which is negative, so it's going to be positive 50 plus or minus the square root of b squared, which is 50 squared, minus 4 times a times c, so it's times 6 times 75, all divided by 2 times a, which is just going to be 12. And I'm going to let y'all type that one in, because seems like the thing to do.
That was exhausting. That was literally so exhausting.
Exhausting.
The teacher was not saying help. What did you do with herself? Really? Are you dressed up? I know one kid had a meltdown because she didn't know
She was like, I was like, are you dressed up for color day? She was like, I don't know. And then I was like, because she was wearing a pink dress, but I couldn't see what pants she was wearing. And then I saw her pants, and I was like, okay, come on. And she was like, I don't like picture day. And then she was gonna start crying, and I was like, no tears are needed for this. No tears are needed. Just come get the picture, even if you are dressed up. It's okay.
That's great. Do you have them on your phone or did she take them?
She took them.
Okay, I'll have her upload those later then.
That's unfortunate.
Is she not in there?
No.
Oh. Can you upload those pictures? And can you like create a folder that says like color day or something like that, Spirit Week color day?
Absolutely.
So that way we actually have it by day, so we're not sitting there trying to guess if somebody was color day or wacky tacky day or
Yeah, you said Spirit. Say one more time. Spirit Day, Spirit Week, Color Day.
yeah.
You need to tell Trevor to add to the list of things that they can't elaborate on the shoes. Got it. Yes. Okay.
I was walking out of the building earlier to go to the office, and
Are you recording?
oh, okay. Anyways,
That's
Miss Ikins was like, Miss Quinn, and I was like, huh? And she was like, oh, it's Alyssa. You guys look the same from the back, and I was like, okay.
I've gotten that with Hope before. I don't think I've ever heard that
Yeah.
with you. I mean, I guess from the back I can maybe see it a little bit, but.
Oh, yeah, I don't know. I was just so confused. And she was like, Miss Quinn, and I was like,
Senior Kevin used to say that like you and Sarah look so much alike, and I was like, no.
Awkward. I saw him at the gym a couple times. That was really weird.
that is
He goes to the
awkward.
gym. Are you sure?
Mm-hmm. Did y'all get an answer?
Yeah.
I did not hear the best things about Kevin.
I didn't either, but you know, whatever.
What is happening right now?
Did we get an answer to this?
Well, there's no perfect square to 700, so I didn't know what to do.
Is this 700?
Yes.
Okay, so
Wait, is this shared sort of folder?
this.
No.
Yes.
Okay. So then
Oh, yeah.
7 and 100. So we could break this into
Okay.
50 plus or minus the square root of 7 times the square root of 100. Right.
Yeah.
So then this would be 10. So 50 plus or minus 10 square root of 7 over 12. I can take a 2 out of everything. So that gives me 25 plus or minus 5 root 7 over 6. And then I think if you actually do this divided by 6. Oh, nope, that was not what was supposed to happen. 38.2287 divided by 6. Okay, the positive one is 6.37. The negative one, 25 minus 5 root 7 divided by 6 is, so then the negative one is 1.96, which is what we said the x value is. So if we took this and we plugged that value back in, that would give us our max value. It can't be this 6.37 because we can't take 6.37 out of this side and this side and still be left with 10. Or like something left over. So it's kind of like you're dealing with like measurements. You have to think about like, okay, what makes sense? So like I can take a 2 out here and a 2 out here and I'm left with 6 here. You know what I mean? But if I take a 6 out and a 6 out, I'm left with negative 2 and I can't have negative 2 for a base of a box, basically. Oh. When you did the minus one, 25 minus
Well, I did.
5 root 7 over 6. Because I got like 11
it's
something.
fine. Now it's still fine. It just can't work for this.
It's usually helpful.
Yeah, because I still have 5, and for some reason my brain translated it.
All right, so that was part D of that one. So, all right, number 26, our last one here that we'll do is minimizing average cost. Suppose C of x is equal to x e to the x minus 2x squared, where x is measured in thousands of units. Is there a production level that minimizes average cost? If so, what is it? So, what? Is that a formula? Hold on a second. I have something written down here and I'm not sure why I have it written down, so I'm looking to see if it's a formula or what. Yes, it is a product rule. So, what does that product rule give us?
E to the x plus x e to the x.
And then what's the second part?
Minus 4x.
Okay, so this is marginal cost. And then this next thing I'm going to give you, I think, is a formula. I just can't find exactly. Oh, never mind. It's on page 229. It says that marginal cost is C prime of x, and then average cost, which is what I'm about to write down, is C of x divided by x, which is then, for our case, we divide by x, we're left with e to the x minus, take out an x out of this one, 2x. So that is a formula, is that marginal cost. So C prime of x is equal to C of x over x. Or, well, that's the way they have it written. Anyways, it's, yeah.
What's the x value?
Huh?
What's the x value?
What do you mean? What is the x value?
Because it's c of x over x.
We're just getting rid of an x is all we're doing. We're just like dividing by x, the variable.
Okay.
And then we'll replace it in a little bit. So now we can set, because of this, okay, we can now set these two things equal to each other. So e to the x plus
These are, like,
x.
two different things with no correlation to each other.
Correct.
Okay.
Yeah. Minus 4x is equal to e to the x minus 2x.
Because I thought we were taking something like the other one that was like, isn't it 2ex minus 4?
Yeah, no, we just set them equal to each other, and yeah. It's kind of weird, but yeah. So, this is what allows us to do this step here. And again, that's just a thing out of your book. That's just a fact that they give us. So now I want to simplify this stuff down as much as possible. So if I move this e to the x over here, it goes away. So I'm going to go ahead and get rid of those. And then if I add this 4x over to the other side, that's with x e to the x is equal to, what is that, 2x? Then I can divide by x on both sides. And then, do y'all remember how to do this? Yep, the L thing. So,
Log
who
base
is calling
e,
me?
2. X equals log base e. 2.
So ln, yeah, log base e, which is ln, is equal to 2 to the x. Or sorry, not hello. What am I writing? Ignore that. I don't know what I just wrote.
ln 2 equals that?
Yes.
Okay, okay.
The tennis center's calling me back, and I was like, I don't know why they're calling me, so I like got distracted and just wrote it down. The tennis center. I called them earlier, and they were like, you need to give us our schedule, get your schedule in, because other teams already have it reserved. And I was like, you have like 25 courts. and I was like, well, you do know that we overlap a lot with the other teams, right? And they're like, oh. I'm like, if it's a match day, typically a lot of times we are playing one of those schools, like just the way that it works out. Anyways. Because Hampton Christian actually has a team this year, and they use Huntington as well. So.
We'll be able to see the practice and say, us. That's cool, I guess.
So then, this is just a number. I don't know what it is, but anyways, it's a number. So then, second derivative test to figure out what the minimized cost is. So we take the derivative of c of x over x. So we're literally just taking the derivative of that there, which would be what? E to the x minus 2. And then second derivative of that. So d2 of x. So what would the derivative of this be? E to the x. So therefore it's positive for all x, because there's no way that that can ever be negative with what we're given there. So therefore it's a minimum. And let me make sure that is in fact all that they wanted from us on that. They have some other stuff written there, but that's all they wanted us to do. So as far as this goes, problem-wise, what I would recommend you look over and try 3, 9. I don't even know how that just happened. 19 and 25.